All right, part 3, factoring special forms. So I will let you know that there's only going to be two that we're going to be talking about, factoring the difference of two squares and factoring the sum and difference of two cubes. So most importantly, I will let you know the first one is completely optional. If you don't want to learn this, if you feel very shaky on the other stuff, you can always do what we're about to do using it the longer way, right? Using either the x squared plus bx plus c method or the a squared plus bx plus c method, right? Anything from those last two videos, you absolutely can do. That is not a problem at all. However, this is just kind of a shortcut. So if you want to know a shortcut for some types of problems, here we go. There's a couple of other shortcuts. This is the biggest one that I think would be the easiest for us to just identify by looking at it. So, difference of two squares. So difference means subtraction. Two squares means you're squaring numbers, right? So if you have something squared minus another thing squared, what that ends up being is the sum of the two terms times the difference of the two terms. And we can actually look at that, right? We can kind of prove that. If we go backwards, right? We have a plus b times a minus b. We've actually already shown that this works, but we can talk about it again, right? So that's a times a minus b plus b times a minus b, right? A times it, b times it. So we get a squared minus ab plus ab, if we just do them in alphabetical order, right, doesn't matter, minus b squared. Since these two terms cancel, we get a squared minus b squared. So that's what the difference of two squareds are. So in other words, the difference of the two squares, they form a product of a sum and a difference of those two terms. So if we know what those two terms that we're squaring are, so as our shortcut, we can just say it's adding those two terms and subtracting those two terms. So let's look at an example. So if we have x squared minus 4, so basically we need to know what are we squaring minus what are we squaring. So x squared, what's being squared? Obviously the x, right? Super easy. 4, what's being squared? What squared is 4? Now, not what is 4 squared, that's not what I'm asking, it's what squared gives you 4. So we're taking square roots. We see it's 2, right? So we end up with x plus 2, x minus 2, and that's it. That's the shortcut. And we're done. So let's do something a little harder. So we're thinking this might be a square scenario. So 81x squared, what is being squared here? Obviously the x is being squared, but what number squared gets you 81? Well, if we know our perfect squares, if we know our times tables, we would know that 9 squared is 81, right? So that's 9x squared. And then what squared is 49? We should see it's 7, right? 7 squared is 49. Good. So our terms being squared are 9x and 7. So this is going to be 9x plus 7, 9x minus 7. And we're done. That's it. All right. Let's look at a couple more examples just to make sure we're feeling okay. So again, what squared minus what squared? So we get 9. Well, 9 is 3 squared. And then we have 16x to the 10. So what squared gets you 16x to the 10? So what squared gets you 16? You see that's 4. What squared gets you 10x squared? Or gets you x to the 10. Well, if you remember, if you have a power raised to a power, what do you end up doing with those two numbers? You have a power raised to a power, what does the law tell us for that exponent? So remember, we're going to multiply. So we are multiplying those two numbers. So basically, what times 2 gets you 10? 5. So that's x to the 5th, right? Because x to the 5th raised to the 2nd power, you multiply these two numbers and you get 10, which is what we wanted. So these are our two terms. So we can see it's 3 plus 4x to the 5th and 3 minus 4x to the 5th. There we go. You don't need to really worry. So we won't worry about anything like that, right? If it's something that looks a little crazier where we have a 5, that's a little too much for this class. So if it has something crazy like a 5, we don't need to worry about it. So we'll just say that that's simplified, because it is, for our purposes. All right, let's look at this one. So what squared minus what squared? 25x squared. So hopefully we would see that is 5x. 5x is what's being squared there. And then we get 4y squared. So that would be 2y, right? Square the 2, get 4. Square the y, get y squared. So using our two terms, that's 5x plus 2y, 5x minus 2y. And again, you can do all these problems the long way. It's going to take you a lot longer. All right, example number 3. So let's figure this one out. Well, so there's not really anything that's being squared here. So maybe we can do a greatest common factor, right? Is there a greatest common factor here that we could take out? Yeah, there is, right? We can see that it's actually 3x. So we can see this is the same as 3x times what? So 4 times 3 is 12. X squared times x is x cubed. Minus, and then what times 3x is 3x? 1. All right. So now we're going to ask ourselves, right? What squared minus what squared? So 2x being squared will get you 4x squared. And then 1 squared will get you 1. So we end up with 2x plus 1, 2x minus 1. However, is this our answer? Are we done? No. What did we forget? What was a super important thing that we forgot? The 3x, right? We also need to include that 3x. Good. That's our final answer. All right, let's do another one. So 125, that is nothing squared, unfortunately. So let's see if we can take something out of these first, which is what we should always do. We should always try to see if we can take some greatest common factor first. Makes things a little easier on us. Well, we can definitely see that we can divide both these numbers by 5, right? Because it ends in a 5 and a 0. So if we take out a 5, what do we end up with? Well, I don't know off the top of my head. So 80 divided by 5, 5 goes into 8 one time, multiply, subtract, and then we got a 6. So 16 minus, and then 125 divided by 5 is 25. I do know that one off the top of my head. So, right, if we already factored something out. So if you want, right, at the very bottom of your problem, you can just write answer. Make sure you include that 5. 5 has to be included. All right. So what squared minus what squared? 16 is 4 squared. 25x squared, we see that's just 5x, right? 5 squared is 25. X squared is x squared. So 4 plus 5x, 4 minus 5x. But as we already know, that's not the final answer because we have to have a 5 out front. All right, and that's it. Let's do one more, and then we'll talk about the thing that actually is super important you have to know. There's really no other way to factor except for this new way. All right, so let's look at it. So what squared? What squared? Well, first, can we take out a greatest common factor? Maybe that can make things easier on us. No, right? First term doesn't have any numbers. Second term doesn't have any letters. So no greatest common factor. All right, so 84, or sorry, x to the 4th. What's being squared here, right? hopefully you saw that it's 2, right? Because when you do an x squared squared, you end up multiplying these two numbers to get x to the 4th. And then we already said 81, right, is just 9 squared. So we get x squared plus 9, x squared minus 9. But uh-oh, we have squares, so maybe we can go even further, right? Let's look at the x squared plus 9, right? So what two numbers multiplied gets you 9, adds, gets you what? 0, right? Remember, this is 0x. So when we multiply these factors, what do we get? We get 1 and 9, 3 and 3. If we add these together, 1 plus 9, whoops. So 1 plus 9 is 10, not 0. 3 plus 3 is 6, not 0. Let's try negatives. -1 plus -9, -10, not 0. -3 and -3, -6, not 0. You may think, what about +3 and -3? Right? Those add up to be 0. However, when you multiply these two together, you get -9, not +9. So, doesn't work. So none of these work, right? Which means that this is prime. Which is good. We don't have to worry about factoring anymore. Woo! So let's look at the x squared minus 9. Well, if you notice, we actually have a square minus a square, right? A difference of squares. And that's going to be x and 3. So I can simplify to x plus 3, x minus 3. So when you get everything all together, right? So we know that our answer is x squared plus 9. That was prime. And then the x squared minus 9 turned into this. So we can substitute that out. So we get x squared plus 9, and then x plus 3, x minus 3. And that can't simplify anymore. Cool, cool, cool. All right, now here we go. The sum and difference of two cubes. So this is super important. This is the only way that you can actually solve these problems. And you're going to need to know this, especially if you continue on in your math career. This is going to be a very important one. So the sum of two cubes. Sum means adding. So if you have two numbers cubed being added together, what we can do is we know that that's a plus b times a squared minus ab plus b squared. If it's the difference means subtracting. So we get a cubed minus b cubed equals, so it'll be, I don't know what is happening here. Nope, there we go. Okay, something's not happening. There we go, a minus b times a squared plus ab plus b squared. So if it's the addition, right, then it's x plus b, a squared minus ab plus b squared. If it's subtraction, it's a minus b, a squared plus ab plus b squared. So if you notice, the letters are the same no matter what, right? A, b, a squared, ab, b squared. So the question is, how do you know about the signs? Well, to get the signs correct, just remember SOAP. So SOAP means this. If you have a plus, the first sign is going to be S, the same sign, right? If you start with a plus, it ends with a plus. If you start with a minus, it ends with a minus. Then you have O. The next sign is opposite. The opposite sign. All right, started with a plus, now you have a minus. Started with a minus, now you got a plus. And then the last one is just always positive. Which is where you get AP, always positive. So same, opposite, always positive. So that can be the way to remember it. Also, good thing to know, this term is always prime. So even though it has an a squared, right, since it could have an x squared, we never need to factor. It's always prime, which is good for us to know because we don't have to factor anything else after that. All right, so let's look at an example. So we get x cubed plus 8. So what cubed plus what cubed? So we see it's an x, and then what cubed is 8? 2, right? Because 2 times 2 is 4. 4 times 2 is 8. Good. So, all right. It's the first term, second term. So remember, it's the first term, second term. First term squared. Both of them being multiplied. And then the last term squared. So remember, it's SOAP. Same. So it starts with a plus. So same. Opposite. Always positive. So if we simplify this, we get x plus 2, x squared minus 2x plus 4. And like we already said, that's prime, so we're done. That's it. Hopefully not too bad, just more things to remember. All right, let's look at this one. So, what cubed minus what cubed? So 27 is 3 cubed, right? 3 times 3 is 9. 9 times 3 is 27. Hopefully after doing some of these a while, if you do them a lot, you'll start to see these patterns that just keep coming up over and over again. So our first term is 3y. Then we get y cubed, 3y, y cubed. Or sorry, 3 squared, 3y, y squared. All right, so remember SOAP. So the first term is same, so it's minus, opposite, plus, always positive, plus. So if we simplify it, right, we get 3 minus y times 9 plus 3y plus y squared. And that's it. You don't have to flip this around if you don't want to. You can leave it just like that. I'm totally cool with that. Last one, and then we're done. So quick video. All right. So what cubed plus what cubed? All right. So this is about as high as you're going to have to know, especially if you don't use a calculator. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64, which is where we're getting that. And then 5 cubed is 125, excuse me, which is where we get that. So that's about as high as you're going to have to do, especially without a calculator. So just kind of having these in the back of your mind might be a good thing to know. But like we said, the thing that's being cubed for the first term is just 4x. For the second term is 5. So we have 4x, 5. Now the thing right here, right? The whole term, the first term is being squared. So we're not just going to write 4x squared, right? Because the 4 is also being squared. So 4x times 5, and then 5 squared. Remember, it's same, opposite, always positive. So plus, minus, plus. To simplify things, make them look pretty, we get 4x plus 5 times 4x squared is 16x squared minus 4x times 5 is 20x plus 5 squared is 25. And that's our final answer. All right, one last thing, and basically we've already learned all of it. Now we're just going to put it all together. What's a strategy that we can do to where if we get any problem, we definitely know we can just do a checklist of what to do. That's what we'll talk about in the last video.